Thank you, Paul. Good morning, everyone. Hope you had a good coffee during the break. So for those of you who don't know Catchoom, so we are a platform that provides computer vision solutions for image recognition, object recognition, and augmented reality. So as you can imagine, a software as a service with content management system, cloud infrastructure, etc., with the corresponding SDKs. But I won't be talking about this today. This is more of a talk that I'm giving tomorrow. Today I will focus on these three things. So we have been looking at the training and maintenance for augmented reality, some of the commercial solutions that you can see across the floor, and some of the limitations there. I'm going to talk about our solution for object recognition without markers. And finally, I will give some notes about our experience with depth sensing cameras and how it worked for us and what we see needs to be done there. So, as you have probably already heard, and you will hear throughout the day, there are solutions like this one for training and maintenance, and the idea behind those applications is that they can give a field operator information about a certain machine, such as learn how to manipulate it, or information that comes from a remote assistance system. So they can provide guidance, they can provide real-time data from, for instance, a connected device, like the heat of the equipment or if there's too much pressure on a valve. If we look at those commercial approaches and how they're solving it today, we can find this couple of examples that show that some of those solutions rely on markers. Here I'm picking up a solution from Ngrain and another one from IQ Agent. And these are excellent tools, of course, for field operators. And what you can see on those images, if you pay attention on both of them, is that on one hand side they are using fiducial markers to help the recognition and the tracking, and on the other one they're using a QR code to identify the equipment. So this, of course, requires an extra step of placing those markers, which in some cases can be a stopper, either because depending on the application or the environment it's not suitable, or simply because the customer doesn't want them. Okay, so another source of information that is used by some of the systems out there rely on 3D CAD models of the object that we want to augment in order to track them. Okay, so this is a model that is digitized, and it's helped tracking system, for instance, based on edges. So for us, it was a bit shocking. We were collaborating with a car manufacturer, and it turned out that it was impossible to access those CAD models. Okay, and if you think about it, it makes perfect sense, because from an intellectual property, those designs are very valuable. So handing them to an integrator is not possible. Okay, so either you have a direct collaboration with that manufacturer, or if there is an integrator that has to access this data, they also have to be in close collaboration. So we thought, okay, let's look at this problem and try to solve it without CAD models. The other day there was a webinar hosted by the area, and in that webinar there was Thomas Perper from Diota, and he said something that I resonate a lot with. He said, well, augmented reality for enterprise becomes really useful and interesting when humans meet complexity. And when I thought about it, I thought, well, actually what I would like to take that statement and make it part of our mission. And the vision that we have at Catchoom is that in order for us to help this industry, what we want is to make it less complex. Okay, so that's how we approach this. For us, providing a solution, as I said, we are a computer vision company, and what we developed is to help the setup by connecting the equipment itself directly with the digital content. Okay, so we got rid of markers. We recognize the object itself, and we are basing our algorithms and our technology only on images and depth. So there is no input to the system based on a CAD model. The solution that we have built is solves kind of two things. So it is textureless. We are not implying that the equipment has a certain pattern on it or that it has a very complex shape that we have to rely on. So even if it's quite a simplistic object, so a part of an engine, for instance, we could identify it, and it runs entirely on the device. So if there's a requirement for the solution not to be connected to any external service, because I don't know, in some cases for security, you have to get rid of Bluetooth, you have to get rid of Wi-Fi. So we wanted to run entirely on device. So here's a small video demonstration of what we did. As you can see, the operator can follow the instructions on the iPad. The first thing that he did was scanning the actual setup, and we immediately captured that as the two objects, the electro valve on the right and the manual valve on the left. Okay, so the funny story is that after we did this prototype and this demonstration, so the actual app, we went to the website of the manufacturer of the electro valve, and it turns out that their instructions were exactly the ones that we were giving. So actually, if you want to learn how to manipulate that, you can come to us. So now I'm going to enter into talking about depth cameras and our experience with what we have seen so far. So for those of you who are not familiar, a depth camera is a device that provides the distance from the camera to the object at every pixel of the image. And they work in different ways, but the most common ones are through an emitter that sends a pattern in the infrared domain and captures either the time that it takes for that light to come back from the object, so it reflects on the object and comes back, or by looking at the deformation of that pattern. Okay, so at the end, we are basically in the physical domain, and we have an active camera that is sending a signal through light that we don't see, of course, and is capturing that light back. There are several commercial depth cameras in the market, and this one, for instance, is the structure sensor from Occipital, but if you have kids at home and they use Microsoft Kinect, you already have a depth sensor at home. Our experience, so we tried these three, the Microsoft Kinect, the Intel RealSense, and the structure sensor from Occipital, and what we learned was that they provide similar performance, but don't take me wrong. So what I mean is not exactly that they provide exactly the same performance, but with small changes. So from one, you can expect that it performs better on some surfaces, whether on another one it performs better on another type of surfaces or material. So they kind of change a lot, but what you can expect in average is rather similar. And what we saw is that actually the key to success, at the moment at least, for those cameras comes from software, but at least with what we find in the market. But we are already working on solutions based only on RGB, so only on the typical camera, in order to also facilitate this kind of solution. So if we think about light, so the problems related with light are basically, if you compare outdoors with indoors, so the sun is too strong, and the emitter, either it is super strong or the typicals, like the one that I showed in the previous slide, doesn't have enough power to compensate for the strong light that comes from the sun. So my recommendation is to work indoors with those cameras. And as for materials, well, they have different reflective properties. So if you have done some optics or physics in your studies, you know that they reflect light differently. And so speaking about materials, did you ever realize why there is so much augmented reality in Iron Man? So we discovered that it's because everything is in red. But there are other superheroes that think differently. So what happens is black is not a good choice. So if you are manufacturing, please choose gray and not black. If you want to do pink, that would be awesome, but I don't think you will accept that. Anyway, my suggestion here is that we take a look at those cameras carefully, and we use them together with software, and computer vision software can compensate for some of those things, but still there are some facts about the physical world that we cannot compensate. So a few takeaways. We do believe that the future of training and maintenance is augmented. We are a contributor to the Augmented Reality for Enterprise Alliance, and we believe that that's the path, and we will all see what's happening in the expo floor and how this will get integrated into industrial solutions. As I explained today, we have worked on a solution without markers and without using a 3D model to still recognize engine parts that are textureless. And finally, as I said, some thoughts about depth sensing. The physical world is still challenging, and software helps a lot. So thank you very much, and please come by our booth to see a live demonstration.